Okay, so the concept of matter as being anything with mass and volume is great because it describes just about anything we can see, touch, feel, smell, all that. But it's really a broad general term. And it doesn't do us much good if we want to work with different kinds of matter and get a sense as to what they're all about. If we want to organize things, for example, we need a better way of classifying matter. And so that's what we're going to look at in this video. Okay, so we'll start at the very top, matter. That's everything, right? Anything with mass and volume. Let's break it down into two varying areas. We'll call one substances, and we'll call the other mixtures. Now, it might be a good idea for your own self and for your notes to actually create the diagram that I'm doing in this video in your notes. Write it down, draw it out. It's really helpful to actually have it in front of you when you're looking at some of these things. So if you need to stop the video as we add to this, go ahead and do that. Stop the video and then draw it so that you have it in your notes. You'll need it. So what do we mean by substances and mixtures? Let's take a look at the difference between those. So substances have what are called a uniform composition. That means that any sample of a substance anywhere in the universe will look exactly the same. It will have the same composition. It will be made of the same kinds of particles. All of the water in the universe, and yes, there are other places in the universe where there's water. They've found water on Mars. They have found water in comets. Any water anywhere in the universe, it looks identical to all other water, even the water on this planet. There's no way to tell the difference between where you got a particular sample of water if it's pure. Okay, so another word that we use to describe substances is pure, made up of only that kind of atom or molecule. Okay, all substances consist of one phase. Phase is something that has its own set of properties. And so a substance, because it's a uniform composition, it looks the same throughout its entire volume or its entire area. Okay, there aren't areas that look different from others or that have different properties. One phase, all the same properties throughout the entire sample. Mixtures, however, are different. So a mixture is actually something that has variable composition. It's made of two or more substances that have been blended together physically. No chemistry is done to make a mixture. You just put stuff together and mix it together. You blend it together. Okay? But because of that, mixtures have a variable composition. That means depending on where you get the mixture, it's what it's made of, and the percentages or the ratios of what it's made of is going to be a little different. Think of air, for example. The air in Madison has certain composition to it. But if you go to Denver, for example, which is a mile above sea level, a mile above where Madison is, there's a little bit less oxygen in that air. You may have heard of that. If you've ever been to Denver, you might know it's a little hard to get used to breathing there. Well, air can't be a substance then if its composition changes based on where you are. Okay? That means it's a mixture. It's a mixture of gases. The nature of mixtures is that the components of the mixture, the things that are mixed together, are just mixed physically. They're not interacting with each other in a chemical way. They're not reacting. Okay? And that means that we can separate a mixture just by doing something physical to it. Sometimes it's easy. Let's say you have a mixture like garden salad, and you don't like tomatoes. I don't like tomatoes. I know, I don't like tomatoes. Sorry, don't judge. I can pick my tomatoes out of my salad. I'm separating out that component of the mixture, just physically. I'm not doing any chemistry. Imagine doing that at a restaurant. No, I just pull the tomatoes out. That's a physical separation, right? What if the particles are really hard to see together? They're hard to look at. For example, you have salt and water and you want to separate salt and water. Well, you might have to do something a little bit more involved. You're still not doing chemistry. You're just physically changing one substance in the mixture into a different phase, for example, a different physical state to separate it out. But it's all physical, and it can be done, and it's not all that difficult to do. You'll have some practice with that later on. Okay? So we have substances and we have mixtures. Well, substances, pure stuff. We can separate that. We can divide that into two other areas. We can call them elements and compounds. Now, we spent a lot of time already looking at what elements and compounds are all about. We know about elements, right? We know that they're the building blocks. They make up everything. There's 118 of them or so, right? They're made of one kind of atom. Now, forget isotopes for the time being. When we talk about the identity of an element, remember, we mean protons and electrons, right? So they're made of one kind of atom only. You can't break an element down into anything simpler that is still matter, okay? Can't be broken down. Compounds, two or more elements that have been combined chemically. What that means is that the compound has different properties from the elements that make it up. I'll give you an example. Hydrogen gas, colorless, odorless, lighter than air, flammable. Oxygen gas, colorless, odorless, lighter than air, flammable. Combine them chemically, you get a molecule called water. And water is colorless, yes, odorless, sure, but it is not a gas. It's a liquid. And pretty sure it's not flammable, right? So even though it's made of two flammable gases, water isn't flammable because it's a new substance, because hydrogen and oxygen have been combined chemically. That's what makes a compound. The elements have to combine chemically. You're not just mixing them. You're causing some kind of change to happen between them to make a new substance. Okay? You can't break a compound down physically. I cannot boil water and get hydrogen and oxygen back. I can't do anything physical to get those hydrogen and oxygen atoms to separate. I have to do chemistry. I have to add lots of energy to do that. It's a very common misconception. Some people think that when you boil water, it turns back into hydrogen and oxygen. It does not, because think about what happens if you boil water over a flame. Boom. All right, so elements and compounds. We know elements are made of, we've got metals, we've got nonmetals, and we've got semimetals. And we know compounds, we have ionic and molecular. We've done all of that, okay? So further dividing those subdivisions into further subdivisions to help us classify, okay? What about mixtures? Well, we're going to talk about two types of mixtures, homogeneous and heterogeneous mixtures. All right? Homogeneous mixtures. Now, homogeneous mixtures have one phase, and a lot of times people will confuse them with pure substances. But the important thing is that for homogeneous mixtures, which we sometimes call solutions, the composition is still variable. I think of Kool-Aid or lemonade. Depending on who makes the lemonade, they might use a little more of the powder or a little less of the powder. It's still lemonade, but it's made differently. Its composition is different. Look at this picture, okay? The first three test tubes here contain a bluish sort of liquid. They're all the same mixture. They're all mixtures of copper-2 sulfate and water. What's different is how much copper-2 sulfate is in the water. The one all the way over here on the right is just pure water, and so you can see the difference in color. All of these are the same mixture. They all are one phase. I can't see any part of each individual test tube that looks any different. It looks like it's one thing, but it's actually two substances mixed together, copper-2 sulfate and water. And the amount is different in these different test tubes. So it has a different, what we call, concentration. Now, I can still separate mixtures physically, even if they're well mixed like a solution, like a homogeneous mixture. Heterogeneous mixtures are not very well mixed. They have multiple visible phases. They're much easier to see, like a tossed salad or soil from the garden. You might have little bits of bugs in there, or mica, or different rocks. Chocolate chip cookie dough. That's a great example of a heterogeneous mixture. You can see the different phases, the chocolate chips, the dough, the nuts in there if you happen to like that. And therefore, heterogeneous mixtures are a lot easier to separate. Usually you can just pick out the pieces with a pair of tweezers or something. Okay? The whole point of doing this is so that we can make sense of the different kinds of stuff in the world, so that we can use them. Just talking about everything as matter is not really useful. But being able to say, oh, I'm talking about a specific type of matter, a substance, it's a compound. Specifically, it's an ionic compound. Well, now I know a lot more about the properties of that without even knowing or seeing the substance. Just classifying it tells me a whole lot about it. So that's why we do it.